All right, how you doing, Christina?
I'm good, Dan. How are you?
It's good to see you. All right, so Christina, I'm just going to talk to the audience, like watching the website or on YouTube right now, just for a second,
Okay.
just to explain like what this is. But all right, so basically, everybody who's watching, I just wanted to. So I've been doing Skype tutoring for a while, and I've been doing in-home tutoring for a while too. But the Skype tutoring has been going very well, and I thought that it would be interesting to kind of showcase to everybody what a Skype tutoring session looks like with me, basically. And Christina is a good friend of mine, and she has volunteered to help me do that, to showcase the tutoring session. And I'm just going to basically teach Christina, my friend, something about systems of equations, just in a short video. But I just want to give everyone a feel for what a Skype tutoring session with me looks like. But anyway, it's worth mentioning that we're pretty far apart also. We're on like literally opposite sides of the country. So it's good to kind of highlight the fact that Skype obviously makes it so that geography is not a barrier, for tutoring. But anyway, so Christina, how are you? You good?
I'm good.
Are you
There's a
ready?
cat on the table. Can you see
Yeah, I like cat. Your cat's very,
him? He's very cute.
I like cats. I like cats and dogs. But all right, so let's I say we dive in. So basically what I like to do, Christina, I'm going to share my screen and I'm going to kind of go back and forth between like a whiteboard and a picture of like various problems. I'm going to
Okay.
start with the whiteboard and just kind of give you a brief lesson of how to um, do something that has to do with systems of equations. All right,
Okay.
and I'll explain it once we're there, but I'm going to share the screen for now. And just let me know if you could see yourself. Probably.
It's like flipped around. It's weird.
All right, do you see the whiteboard here?
Mm-hmm.
Okay, good. All right, so here is the lesson. So basically, we're going to do systems of equations, and let me first explain what the heck a system of equations is. So typically, in a math class, what they'll do is they'll give you two equations, both equations featuring an x and a y variable. And here is what it looks like. So for example, they might give you something like 3x plus y equals 5. And they might also give you something like 7x minus y equals 15. Now, before I dive into this, does this at all like ring a bell from what
Yeah.
you've done in the past? Right.
Mm-hmm.
So then I'll ask, do you actually know what to do from here before I dive in? And if not, it's fine. That's what I'm here for. But just checking.
I
Like,
don't remember. It was a
yeah.
long time ago.
All right,
I
good.
remember there's like PEMDAS, right? That's what I
Yeah. Yeah, that's not going to apply as much here. But I'm
Okay.
glad you don't know because now I feel useful. Okay.
Good.
So, all right. So basically, there's really three different ways to solve this. And when we say solve it, basically we want to figure out what is x
And what is Y?
and what is y. Yeah. And to sort of translate this into like just normal layman's terms, basically it's like 3 times some number plus some other number equals 5. And 3 times that same number, that was here, minus that other number equals 15. So it's almost like they're giving you clues and you have to be a detective to figure out, what is x and what is y. Now, it so happens that there's like numerous ways to solve these. Okay, there's 3 like really famous ways to solve systems of equations. I'm going to present to you a way called the elimination method. In fact, I'm going to write that. Elimination. And sometimes they call it the addition method as well. All right, but this is the elimination method. And basically what you have to do is you sort of look for any opportunities to cancel out a term. All right. Now, the bottom line is we have a positive y right here, right? And we've got a negative y right here. So the bottom line is if I was to add the top equation to the bottom equation, this positive y would cancel out the negative y. Does that sort of make sense to you?
Yeah.
All right. So that's what we're going to do. And by the way, you can add the top equation to the bottom equation as long as the equal signs are lined up and you've got like the x lined up over the x and the y lined up over the y. And this, we call this a constant. When the constant is lined up over the constant on the other side, then you can definitely add these together. All right. Now, different teachers would place different emphasis on like how much you need to sort of demonstrate that you're adding them, but I'm just going to do this for now. And the bottom line is when you do that, 3x plus 7x, and this is the stuff that you might need a little bit of a reminder of, this would end up becoming 10x.
Mm-hmm.
Does that ring a bell to you?
No, but I would assume that that's what it would become.
Yeah, and it's fine. Honestly, as long as you sort of remember the pattern, because I want you, before we part ways, to sort of demonstrate that you can do it. We don't need to get into the detail as to why that works, as long as you know that it does work. Okay. And we have y, quote unquote, plus and negative y. Well, that actually cancels out, like y minus itself. Well, that's just 0, right? So I don't mind just writing a 0. That's fine. And then we have 5 plus 15, and that is 20, as you know, right? Now, at the end of the day, we don't really need this 0 here. We don't need to write that because 10x plus 0, well, that's really just 10x. So we have 10x equals 20.
Mm-hmm.
Now, my question to you is, when I say 10x, I want to make sure that you're very clear. You understand that this means 10 times x, right?
Yeah.
All right, so good. So in other words, it's basically like 10 times some number equals 20. So just using like common sense or whatever, what would that number be?
2.
Exactly. So that's like one way of approaching algebra or whatever. You kind of bring it to a certain point where you can very clearly see, oh, well, it's like 10 times 2 equals 20, obviously, right? But if you wanted to do it in a way that a teacher would typically recommend, they'd be like, all right, our goal is to get x to be completely by itself. Like, this is our goal. We want x by itself, and we want some number over here. And the way that I like to explain it is like, it's like, all right, we want to get this x by itself. Well, what's in the way of x being completely by itself? Clearly,
Why?
Well, we have this 10 right here,
Mm-hmm.
right? So that 10's in the way. So we have to get rid of that 10 somehow.
Okay.
Yeah. All right, so it's funny. You can make like little cartoons. I like the whiteboard. So we got to get rid of that 10 somehow. Now, the way to get rid of numbers, that are sort of like, in the way of x being by itself, is you have to do the opposite of what the number is doing. So we have 10 times x. Well, the opposite of multiplication is to divide. Yeah, you divide this side by x, but you're not allowed in algebra to divide just one side by 10. I should have said by 10. You're not allowed to just divide one side by 10. You actually have to do it to both sides. All right. So once you do that, you end up canceling these because division's the opposite of multiplication. So you essentially just like destroy the 10 there. And then you have an x by itself over here, which is the goal, right? We want x to be by itself. And then you have a 20 over 10. Now that means 20 divided by 10, right? So what is 20 divided by 10? Well, you know that that's 2.
2.
Right? Now you already said 2 before. Very good. But this is the more like official way of going about it. All right.
Okay.
So we got one of the answers. I mean, we're halfway there. Because it's like, all right, well, x equals 2. But the question is, how do you use that information to figure out what y is? And the bottom line is, it's very simple. All you have to do is pick one of the two equations. I don't care which one it is. Let's just go with the top one, whatever. I'm going to put a little asterisk near it. All right. And we're going to bring that equation down here. Here it is, 3x plus y. And again, I could have picked the other one, but I'm just picking this one, like whatever. All right, 3x plus y equals 5. Well, we already know what x is equal to, right? It's equal to 2. So that means that we could substitute 2 in for x right here. So it's really 3 times 2 plus y equals 5. Any questions so far with that?
No.
All right, so 3 times 2. This is actually, by the way, you mentioned PEMDAS before. This is the first time where PEMDAS really comes into play.
Right.
You do want to multiply 3 times 2 right now.
6.
Multiplication comes before addition or whatever. So we have 6 plus y equals 5.
So
All
y
right.
is -1.
Y equals -1. Beautiful job. Now you were able to do that in your head because you're smart and you can use your common sense and all that. But bottom line is, had you been asked by your teacher to sort of represent what you did there, well, you would know that you got to get this y by itself. The 6 is clearly in the way of y being by itself. So the way to get rid of that 6 is to actually subtract it from both sides this time. You're going to subtract 6 from both sides. And the reason for that is because 6 is currently being added to the y. So in order to do the opposite, subtraction, right? So that cancels that out. And then you have, we'll stick with black, then you have y equals what you just said. We have 5 minus 6, and that is definitely -1. All right. So yeah, that's the answer. It's x equals 2 and y equals -1. Any questions about that?
Nope.
All right, very good. So I actually would rather give you a problem right now to kind of work on so you can demonstrate that you know what's up. All right. And for those of you watching at home, me doing this with Christina, just know that this is kind of part of it. Like, I can have a student like send me a review sheet like this. I can have the picture of it and I can bring that picture up on my screen. And then when I go to edit, I'm able to draw like immediately on the picture. All right. So I'm actually switching to this now. Okay. So with number 1, let's get red. That way it stands out. So with number 1,
See it. Can you make that the whole screen?
yeah, let's see. Yeah, maybe let's take a look. Does that make it a little bigger for you? Are you able to see that?
Can you zoom in a little?
Yeah, unfortunately, when I zoom in, I'm not able to edit it, but that's fine. Here's what I'm going to do. All right, so in case this is ever an issue, I could just kind of put this off to the side and just transfer it over here. So I'm actually just going to transfer it to the whiteboard then. All right, so we're going to erase all this, and I'm going to write it. All right, so number 1 is a plus b equals 0. And then we have a minus b equals 16. Now, is that big enough for you? Can you see that okay?
Mm-hmm.
All right. Okay, now I'm going to give you a little bit of a hint. All right, it might be unnecessary, but I want to, for the sake of like pushing this forward, I will say you can definitely add these two right here, right now. And when you do that, what does a plus a become?
A.
That actually becomes 2a. And I forgive you
okay.
for not knowing. Yeah, that's okay. So basically, just I'll actually tell you what's up with that. So basically, a plus a. The bottom line is there's secretly like an invisible 1 being multiplied to that a, right?
Okay. Yep.
An invisible 1 over here. And then what do? You keep the variable and you add the 1s. Does that make sense to you?
Yeah.
So before we move back to the problem, very quickly, what would 3x plus 4x be?
7x.
Good, exactly so. All right. So that's the rhyme and reason behind that thing. All right, so anyway, we know that a plus a is definitely 2a. What's b plus negative b? What did I say before? Exactly. It's just a 0. So you know what? I'm not even going to write anything.
Right.
And then we have equals here.
Yeah.
And what is 0 plus 16?
16.
Totally. And now I know you could probably use common sense to figure out what a is right now, but if you were to do it the teacher method, what would the teacher tell you to do? Divide both sides by what?
By 2.
Exactly. So we would do that. You would divide, take away these guys, and you'd have a equals what?
8.
8. Very good. Okay. Now you, please, Christina, verbalize to me if we want to find b, what's a good idea at this point? What should I do to find b now? Because we found a. But what about?
Let's just take the top one.
Yep, we'll take the top one. I'll use the asterisk just to make sure that we're clear that it's definitely the top one that we're working with. I'm going to rewrite it so that it's just, what it used to be. Okay, then what do I do?
Then you're going to write 8 plus b.
Exactly. Equals 0. Now, again, you could use common sense if you want, but if you're going to do it the teacher way, what do I have to subtract from both sides at this point?
The 8.
Exactly. So we're subtracting 8, not just from the left, but you have to do it from the right also, in the same way that when we divide it by 2, we had to do that to both sides. That cancels this, and we have b equals what as a result?
-8.
Totally. All right. You got that?
Mm-hmm.
All right. So you're pretty good. I gotta tell you that.
Thank you.
You're welcome. All right.
Let's see
So
what happens when I try to do it myself.
yeah, well, it's good. So we're gonna take it up a notch. I do want
Okay.
to challenge you at least a little bit here. So the next one that's worth covering is this one. So we have
I
two.
don't remember any of this, by the way. This is 100% a refresher course because it's been a long time. So
Awesome.
this is all your teaching.
All right, good. That's what I like to
Yeah.
hear. And also, I like how that sub communicates to the students at home that you don't need this crap in your life. You know what I mean?
I know that's what they say in high school. When am
Yeah,
I
but
ever going to use this?
I know. Yeah, listen, there are reasons to learn it. There is value to it, you know,
Yeah.
but at the same time, it's at the very least, whatever. It's like exercise for your brain.
Yeah.
All right, so this one's a little different, and the reason why is because, yeah, I got a top equation, yeah, I got a bottom equation, but like if I add these, like look what happens when I add them. It's like miserable. We get 2a plus a, well, that's 3a. We got 5b minus 4b, well, it's like, all right, that's 1b, also known as, you know, plus
Just
b.
me.
And then I got -3 over here when I add 11 plus -14.
Right.
Think about it. It's like, did we really help ourselves? We did not eliminate anything in that,
No.
right? So in a sense, we just like wasted our time, essentially, all right? The bottom line is, if you want to do the elimination method, well, you have to eliminate something, right? So the first thing you have to do is you got to ask yourself, all right, can I eliminate something by just adding these? And if the answer is no, which in this case, the answer is no,
Mm-hmm.
then you have to figure out how to make one of the equations or both of the equations such that you can eliminate something. Now, I'm just going to
Okay.
tell you how to do it. Bottom line is, you see this, like, wouldn't you agree that if this was like a -2a, well, then I could eliminate these guys,
All of it. Yeah.
right? But it's not a -2a. So you know what we're going to do? We are going to force it to be a -2a. And the way that we're going to do that is we're going to multiply the entire equation, because you're allowed to do that. You're actually allowed to multiply the entire equation by -2, right? I can't just multiply a by -2. Whatever I do to a, I have to do to everything else. That's like the
Mm-hmm.
rules in algebra. So the bottom line is, once I do that, now this is something called distribution, Christina, that you might not really, you know, remember too well. But the bottom line is you got to multiply -2 here. You got to multiply -2 here and over here. Okay.
Vaguely.
So yeah, we're going to bring this down to the next line. And what it becomes as a result is -2 times a becomes -2a.
Mm-hmm.
-2 times -4b. Well, first of all, I ask you, what's -2 times -4?
-8.
You're very close. It's +8 because
Positive. Okay.
a negative times a negative gives you a positive, and that's going to be a +8b. All right. All right.
Yeah.
What's -2 times -14? First of all, is going to be positive or negative?
It's going to be positive.
Good. And 2 times 14 is what?
28.
Very good. 28. So we literally just rewrote this second equation in a way that's going to be a little bit more convenient for us if we're going to
Right.
use the elimination method. So what I'm
Okay.
going to do is, since this is a big old mess, I'm going to rewrite it over here. And I'm going to rewrite the second equation in such a way that is convenient, which is what we just discovered. It's this -2a plus 8b equals 28. All right, now we are back to the normal situation where we're able to just add these right now. So 2a plus -2a is what?
Nothing.
Good.
Cancels
5.
out.
Beautiful job. 5. In fact, I'll cancel it because you said that. 5b plus 8b is what?
13b.
Very good. 13b. All right, 11 plus 28. What's that?
39.
Beautiful job. 39. Now, if I want to find b, I have to divide both sides by what?
13.
Good. Now, 39 divided by 13, can you do that?
3.
Very good. All right, so we got 3, and I know you know what to do from here. you would just take, we've been working with the top equation, that's totally fine. It would be 2a plus 5 times 3 equals 11. And I'll just finish the rest.
Okay.
So it's going to be 2a plus 15. And just make sure that you're following it. 2a equals negative 4. And then finally, it would be a equals negative 2. Would you agree with that?
Yes.
All right, very good. All right, now I'm going to give you a practice problem with that. I think I'm going to go over one more concept after this, and then we'll call it a day, but this is the second of 3. I'm going to
I wish I had you when I was in high school. This is way easier than I ever learned it.
Yeah, good. Yeah, I mean, it's the personalized attention's good, and also the pace. Like I can tell just by looking at you that you understand it, which is one of the reasons why it's actually more important that I see you than you see me, because I need to see non-verbally if you get it. And when I see that you get it, I'm able to just move along a little bit more quickly.
Right.
All right, so we have 5y minus 3z equals negative 4. Now this one's tricky. No pressure if it's tricky and you need a hint. I'm going to give you a hint. But I do want to give you a moment to think about it. Now, this is my weird handwriting. That's a z. That's a negative 3z. Now, I guess my question to you is, which one would you like to eliminate? Would you like to eliminate y, or would you like to eliminate the z?
Well, the y is going to be 9y, so that's easy.
Well, when you add these together, it would be a 9y, right?
Right.
But that doesn't really help us. That does not help us with eliminating. Now, I'm actually going to jump in and help you with this. You see how this is like a plus z right here?
Yeah.
And this is a negative 3z.
3z, yeah.
Well, this one's already positive, and this one's already negative. So we're kind of close to the situation where you would be able to hypothetically eliminate them, right?
Mm-hmm.
Because that's what we've been doing so far with elimination. You have one of them's positive and the other one's negative, right? Well, that's why I'm sort of tempted to do what I can to eliminate the z's, all right? Now, the bottom line is I can't eliminate the z's yet. But if this had what number in front of it, what would make it so that I could eliminate it with this guy?
Right.
Exactly. So if we had a 3 in front of there, right?
Multiply the whole top equation by a 3.
Exactly so. All right. So this is a nice illustration of how it's not always the bottom one that you're going to want to manipulate. You kind of just have to think on your feet and do what you got to do.
Right.
Actually, I'll bring this down a little bit. So basically, when I do that, I do this like distribution thing, right? Now I'm going to challenge you here. We're actually going to bring it above. We're going to bring the whole thing above. What is 3 times 4y?
12y.
Beautiful. I'm going to write that right here. What's 3 times z?
3z.
Good. And what is 3 times negative 10?
Negative 30.
Beautiful. All right, so we have that. And I'm going to avoid confusion, I'm going to write it again over here. And I want you to literally walk me through, once I write it, not yet, but once I write it, I want you to walk me through all the steps I need to do.
Okay.
All right, not yet, almost there. And I got faith in you. All right, so what do I do from here?
You're going to add the top line to the bottom line.
Totally. 12y plus 5y is what?
17y.
Good. What's
equals
this?
Nothing.
Good.
Back cancels out.
Negative 30 minus 4. What's that?
Negative 26.
Yeah, I understand why you said that. I'm going to give you a brief refresher on that. Negative 30 is right here on the number line, right? You got 0 over here. You got positive 30 over here. So when we say negative 30 minus 4, we're really like, okay, you start here.
The other way.
And then you go 4 in that direction, right? So that's going to be what?
Negative 34.
Negative 34. Good job. Divide both sides by what?
17.
Totally. And, okay, negative 34 divided by 17, is that going to be positive or negative?
It's going to be negative.
Good. And negative 34, what's 34 divided by 17?
2.
Totally. All right, so we've got
Y.
part of the answer. Very nice. And please walk me through, we have this equation. Well, we have this equation right here. I'll put a gobbledygook near it. We have this equation. So we have two to choose from. Which one would you rather work with? It doesn't matter.
Let's do the 5y.
All right, we'll do the 5y. We're going to mix it up a little bit. I don't have to rewrite it because it's right here. So what could I write after substituting -2 in for y? 5 times what?
-2.
Good. And then minus 3z.
Yeah, equals -4.
Good. And then what do I do?
You're going to multiply that.
Good.
So 5 times -2 is going to be -10.
Love it.
Minus 3z equals -4.
Totally.
And then you can add 10.
Amazing. Oh my God, you're expert.
Expert at integers.
Expert alert it up.
Okay. So
all right. So we got, what do we got? These canceled. Thank God. Jeez.
Get rid of those.
Yeah. What do we got over here? What's left over?
-3z
equals
6.
Very good. All right. Divide both sides by what?
3. -3.
Totally. -3. 6 divided by -3. Is that going to be positive or negative?
Going to be a negative.
Good. It's going to be a negative what?
2.
Totally. Boom.
So they're both -2.
Yeah, they're actually both -2. That can happen. All right. That can happen. All right. Any questions about that?
No.
All right. Beautiful job. All right. One more concept, and then we shall call it a night.
Okay.
And you have been very good so far. Very, very smart. Very good job. Okay. This next one is the trickiest one of all. Obviously, we're kind of increasing the difficulty. Here's the next one. 4z plus 3d equals, what is it? -9. And 7z plus 2d equals -6. So.
Okay. I'm just going to get my charger because it's saying it's dying.
Oh, yeah, no problem.
Sorry.
No
I
problem.
thought I had enough battery to get through.
Yeah, no problem at all.
I'm sure this happens at times.
I hope you're pumped for this one.
I'm so excited.
This one's going to be...
What's going to happen? Okay.
I wish all my
4C.
students... All right, so 4C...
You wish all your students sang?
Yeah, you know what? They're excited. They're happy. They all have a good attitude. For my students at home watching, good job. All right, so we got 4c plus 3d equals -9, 7c plus 2d equals -6. All right, now here's the deal. There's no obvious answer as to like which thing to cancel out first. You know, it's like, you know, I can't just like before we had something like z -3, and we wanted to cancel these two out, you know, -3z, and all you had to do is multiply this by like a -3. That's all you had to do, or a +3 rather, sorry, +3. That's all you had to do to cancel them. But now it's not so obvious. This is a slightly harder situation where you're actually going to have to multiply the top and the bottom equation by something. And I'm just going to do it right now. Here's my goal, Christina. If I could just turn this darn thing, this 3D, into a -6D, and if I could turn this thing into a +6D, then I could cancel these, right?
Right.
What do you think?
Mm-hmm.
Now, for the record, I could also work with these two. I could turn this into a -28C, and I could turn this into a +28C, right? But what's the bottom line? If you think about it, I'm multiplying, I'd have to multiply the 7 times the 4 in order to get the 28C. Right. And I'd have to multiply this 4 times the 7, maybe a -7 in this case, and I would get a -28.
Just bigger numbers. That's why you're choosing, right? That's why you're choosing the 6.
Yes, and so we're going to choose the 6 instead because it's less annoying and less clunky. Mm-hmm. Now my question to you is, let's say I want to turn this one into a -6D. what do I have to multiply by 3 in order to get a negative 6d?
Wait, what? Can you show what you're pointing at?
Yeah, no problem. So I want to turn this into a negative 6d.
Oh, okay.
So what do I have to multiply to?
Negative 2.
Exactly. You know what I'm saying? So you get in your head like what the goal is. The goal is to turn it into a negative 6c and a d. And in fact, I'm going to write down what the goal is here. The goal is to turn this one into a positive 6d, but we're going to focus one step at a time. So focusing on the top equation. If I'm going to multiply this 3d times negative 2, well, I have to multiply the entire top equation by a negative 2. Does that make sense to you? All right, so we're going to get rid of this because we already know what our goal is. And at the end of the day, negative 2 times 4c is negative 8c. Negative 2 times 3d is negative 6d, which, by the way, was the whole point. And then negative 2 times negative 9, well, that's going to be a positive 18. Any questions about that?
Nope.
So if we want to multiply multiply 2d by in order to get
the whole thing has to be 3.
Exactly. So we are going to obnoxiously multiply this thing by 3, and I'll do it underneath to avoid crowding. So this becomes 3 times 7c. What's that?
21c.
21c. 3 times 2d is what?
60. Positive 60.
Very good. And we have 3 times negative 6. What would that be?
Negative 18.
Negative 18. Very good. Once again, to avoid confusion, I'm just going to rewrite this stuff over here. So far, we have a negative 8c minus 6d equals 18, which is the top equation. We have a 21c plus 6d equals negative 18. Now, when I add them together, clearly these are going to cancel.
Yeah.
So we already know that. Now, what does the negative 8c and positive 21c become?
Negative 13.
It's actually positive 13.
Positive 13.
Yeah, good job, because negative 8 is a little smaller, right? So it's literally like 21 minus 8. Yeah. And 18 minus 18, what's that?
0. Just
a 0. All right, so when we divide both sides by what?
13.
Totally, 13. And that cancels, and we have c equals, what's 0 divided by any number?
0.
Just 0.
What? The whole
Isn't that crazy?
The whole equation is pointless.
Well, just c. Well, at least c is a 0, right? Now 0 in like math land and math abstract universe land, that's like a real number.
It's not nothing, right?
Yeah, it's kind of a strange like situation. It's like paradoxical. But all right, what do you want to work with? Do you want to work with the top one, or do you want to work with the bottom one?
Let's do the top one.
All right, we're going to shrink it down a little bit. All right, top one.
Let's get rid of all these guys.
Yeah, so we have negative, we'll just do it up here. So we have negative 8 times what?
0.
Yep, because we already know what c is, right? It's 0. So it's like I'll do it in a different color even. Negative 8 times 0 minus 6d equals 18.
All right.
And what does this become? Negative 8 times 0?
0.
Totally. It's like you don't even need to worry about this thing. It's like, get out of here. So we have negative 6d equals 18. All right, divided both sides by what?
Negative 6.
Totally. And I'm just going to erase this. You tell me, what's 18 divided by negative 6?
3. Negative 3.
Yes. Good job. Good catch. Because a positive divided by a negative is
a negative.
That should be a 6. Is a negative. So we have d equals negative
3.
All right. Do you understand that?
Yes.
I feel like you understand it.
I do.
I think you understand it. So I guess my question to you right now is, do you have any questions for me.
No, this is the most easily I've ever understood algebra. No
Yeah.
exaggeration.
That is like what I'm talking about. All right, and can you see me right
Yep.
now? All right, good.
I have my notes.
Awesome. Ah, good job. Awesome. All right. So
Now I can go back to never using algebra and integers.
now you can go back to real life where you don't need this crap. You know what I mean? Although, to be fair, I think algebra definitely comes into play with like Excel spreadsheets and Excel spreadsheets.
Yeah.
Those are important. But
For sure.
and also if like you're, you know, positioning a painting on the wall and trying to figure out how much space is on one side of the painting, how much space is on the other, and to make it sure it's perfectly centered, like things like that. You will be surprised, but
Right.
But anyway, beautiful job, Christina. Thank you so much.
Thank you.
I'm actually going to text you after
Okay.
we're done, and
Sounds good.
yeah, and I'm really happy with it, and I'll talk to you soon. Okay.
All right. Thank you.
All right. Have a good one.
You too. Bye.
Bye.